write, but do not evaluate. And be careful with this one. You can spend a lot of time trying to evaluate this and don't have to. An integral expression that represents the maximum of g on the interval, closed, and then justify. So be careful. Integral expression, maximum value. Value means output. So basically, if this is g, if I want to know my maximum value of g, do you understand? I need to find what x value would give me the max and then plug x in to this. And that would give me an integral expression. So basically, I've got to find x on this interval that gives me the max. So the first two things is check the endpoints. And you say, if you take this function, if I find g of 0, and that would be 3 sine 0, oops, what am I doing? Woo! 0, is that okay? I'm doing the integral of this function right here. I don't know why I wrote that line there. 4 plus t squared dt. You guys okay with that? And then if we want pi, you do the same thing. 3 sine pi. This is 0. So we got to do these two pieces, find out those, and then we got to also find if there's any maxes or mins, relative maxes or mins to check as well. Now, when we do this, we have to find these values. What's sine 0? Isn't that 0? And what's the integral from 0 to 0? Does that make it really easy? Isn't sine pi 0 as well? Aren't both of these a value of 0? So these two end up with 0. So they're both the same height. So they're probably not going to be the maximum. There's probably going to be somewhere in between that's higher than 0. How do we find that spot? Well, to find a max or min, don't you have to take the derivative, which is right here? Isn't the derivative of g? Aren't we going to set this value equal to 0? So we're going to take g prime, set it equal to 0. So we're going to take 3 cosine x square root 4 plus 3 sine x squared. We take that and we're going to set it equal to 0. When we do that, well, what makes 3 cosine x equals 0? And what makes 4 plus 3 sine x squared equals 0? Oh, sorry, we should probably do the square root, but you understand that's just going to drop out. We're going to solve both of these, and we're going to solve them for the interval from 0 to pi. So could I divide both sides by 3? So what makes cosine basically 0? Does anything make cosine 0 on this interval? Does pi over 2?
Yeah.
So this would be pi over 2. Anywhere else on this interval do we get cosine 0? No. So there's 1. This one. Can I basically stop? Because if I square both sides, I move this over, I'm going to have a negative. And then I'm going to square root a negative. Can I stop? Again, you're going to end up with like 3 sine x, and I cannot write today. You get 3 sine x, and this is squared, equals negative 4. And when I solve that, it's not possible. Because you're going to square root a negative. Gives you imaginary. That makes it nice. So guess what? The only one to check is this one. And how do we check to make sure this value is a max? Well, could we take the second derivative of this formula and plug it in? That would be one way, but do you want to take the second derivative of that? No. Would it probably be easier just to take a value on either side of pi over 2 and plug it into this formula right here? That'd be easier to just plug it in here. So let's do g prime. What would be on pi over 2 on the left side? Maybe pi over 4. Because it would be between 0 and pi over 2. Maybe so pi over 4. And then we also maybe want to try, what is it, 3 pi over 4? Do we choose two different numbers, one on each side? So we're trying to find one on each side of this value. And what do we want to find out? We're looking for it to change from positive to negative. So we don't even care about completely plugging it in to get the right value. You just got to see if it's positive or negative. So when you do that, it's going to be 3 times, what's cosine x? Cosine pi over 4. What's that going to be? Positive? Can I just put positive there? Does it even matter the value? No, because I know it's going to be a positive number. And the square root of 4 plus, I need something. Well, is this going to be positive no matter what? It has to be. It's the square root. I mean, if not, it's imaginary, and this value works, so I can just stop. 3 times a positive times a positive. Won't that be positive? And then the next one, when I plug this in, I get 3, and since this is in the other quadrant, isn't this negative? And then this thingy, it's going to be positive. It has to be. So won't that be negative? So, is this a max? This is a relative max. So why is it a relative max? Because g prime x is greater than 0 when x is less than pi over 2, and g prime x is less than 0 when x is greater than pi over 2. Now it's not actually perfect because for the interval, is that okay? On the interval, those two values, this is our justification. You guys see that right there? That's our justification why. This is the relative max. Here's our justification. Now, what we now need to do is write the what? The integral. That's what the whole question was asking for. So basically, here's our answer. And what's 3 pi over 2? 3 times pi over 2, isn't that going to be 1? What's sine pi over 2?
-1.
Sine pi over 2 is 1. 3 times 1 is... Can I put a 3 there?
Yeah.
And then I've just put the square root of 4 plus the t squared dt. Is that the integral? Will this give me the value of pi over 2? Because I plugged in 3.